Hello everyone, welcome back to my channel. My name is Komang Triana. My student ID number is Y91301102A. I'm from class 3A Mathematic Education, Ganesha Education of University. In this video, I will explain to you about one of the mathematics subject matter, namely set, relation, and function. Now, let's start to the explanation. Sets, relation, and function are all part of the set theory. These tools help in carrying out logical and mathematical set operations on mathematical and other real-world entities. Sets help in distinguishing the groups of certain kind of objects, whereas set operation, i.e., relation and function, are the ways we use to connect and to work with set. The first material we will discuss is about set. Set is any well-defined collection of objects. Well-defined is clearly defined. Your answer must be the same. Suppose, for example, you say set of natural number less than 5. There are 1, 2, 3, 4, and 5. Or set of vowels. There are A, E, U, E, and O. All these are well-defined. But suppose you see the good student in the class or best players in Indonesia cricket team. So the answer will be vary from person to person, right? So this is not set. The right set is this. Therefore, set is any well-defined collection of objects. Next. So now about how to denote set. If M is a set and A is one of its elements, we can write like this, which is read as A is an element of M. But if A is not an element of M, then we write like this, which is read as A is not an element of M. Now about representation of sets. For your information, sets are usually denoted by capital letters and elements of set are usually represented by small letters. There are mainly three ways to represent a set. The first is statement form, the second is roster form, and the third is set builder form. In statement form, here single statement describes all the elements inside the set. For example, Phi equals to the set of all vowels in English. In roster form, all the members of the given set are enlisted within a pair of curly brackets, these curly brackets, and they are separated by comma. For example, the set of all even whole numbers between 1 to 10. So we can write like this, which is read as E equals to 2, 4, 6, 8. And the last is set builder form. Here, a property is stated that must be common to all the elements of that particular set. For example, you want to write a set of positive integer between 10 to 20. You can write like this. We read the set builder form as N is the set of all x such that x is a positive integer between 10 to 20. The brackets denote the set, while the colon denote such that. Now it's about type of sets. First is empty set, a set with no elements, denoted by a set of curly brackets without anything written inside it, or by this symbol we can read as P. The second is equal sets, a set with equal elements. The third is equivalent sets, sets with the equal number of members. The fourth is finite set. It contains countable number of elements. The fifth is infinite set. It contains uncountable number of elements. The sixth is singleton set. It contains only one element. The seventh is universal set, a set of all elements in a particular context. Now about subset and superset. If every element of M is also an element of N, then a set M is a subset of a set N, written as like this. We can read this as M is a subset of N, or equivalently, N is superset of M, written as like this. Now about proper subset and proper superset. If all elements of B are in A, but A comprises a minimum of one element which is not present in B, then B is a proper subset of A, written as like this, or equivalently, A is a proper superset of B, written as like this. Now about power set. A collection of all the subsets of a given set is a power set. For example, R equals to 5A. The power set of R is the set of 5A, set of 5, set of 8, and empty set. Now it's about set operations. Let A and B be given sets, then the intersection of A and B, denoted by like this, is defined by the intersection of A and B equals to all x such that x is an element of A and x is an element of B. The second is the union of A and B, denoted by like this, is defined by the union of A and B equals to all x such that x is an element of A or x is an element of B. Please remember, at the intersection defined by the word and, while at the union defined by the word or. Please distinguish between word and or, okay? And the last is the set difference of A and B, denoted by like this or like this, is defined by the set difference of A and B equals to all x such that x is an element of A and x is not an element of B. If U is a given universal set, then the set difference of U and A is called the complement of A, denoted by like this. Do you get it about set? Now it's about the example of set operations. For example, if set A equals to 1, 2, 3, 4, 5 and B is the set of 3, 4, 5, 6, 7, then the intersection of A and B is equals to 3, 4, 5. The union of A and B is equals to 1, 2, 3, 4, 5, 6, 7, and the difference of A and B is equals to 1 and 2. Okay, that's all about set. Now it's about relation and function.
Relation and function are the set operations that help to trace the relationship between the element of two or more distinct sets or between the element of the same set. But before we move on to further explore the topic, it is important to get the idea about the Cartesian product and Venn diagrams. So I hope you already know about Cartesian product and Venn diagram.
The relation is the subset of the Cartesian product, which contains only some of the ordered pair based on the relationships defined between the first and second elements. The relation is usually denoted by R. If a pre-element of a set A is related with one and only one element of another set, then this kind of relation qualifies as a function. A function is a special case of relation where no two other pairs can have the same first element. Look at this notation. This notation denotes that f is a function from x to y. For x element of x, there is unique q, y is an element of y, and his y is represented as y equals to f of x, which means value of f at x, which in turn is the value of y at a specific value of x. Now is about representation of function. The first is algebraic form, the second is tabular form, and the third is graphical form. Now we will talk about domain and ring. The domain is the set of all first elements of R, and the ring is the set of all second elements of R. For example, here are mappings of functions. The domain is the input or the x value, and the ring is the output or the y value. Now it's about type of function. Based on the kind of element that the sets involved consist of, functions can be the first, identity function, i.e. y equals to f of x equals to x. Both ring and domain of the function is the same. The second is constant function, y equals to f of x equals to constant. The ring of the function is constant. The third is polynomial function, i.e. y equals to f of x equals to polynomial for every value of x. The ring of the function is constant. The fourth is rational function. There are y equals to f of x equals to g of x over h of x. The g of x and h of x are polynomial, and h of x is not equals to 0. The 5 is modulus function. The ring of the function is positive plus the set of 0. The 6 is signum function. The ring of f is negative 1, 0, and 1. And the last is greatest integer function. The function assumes the value of the greatest integer. The ring is a pure integer value. Now is another type of function based on the kind of relationship that the elements of the two sets have with each other. There are mainly 4 types of function. The first is one-to-one function or injective. For each element in the domain, there is one and only one element in the ring. The second is many-to-one function. When 2 or more elements from the domains are mapped to the same single element in the ring. The third is onto function or surjective. When every element of the ring has been mapped to an element in the domain. And the last is one-and-one and onto function or bijective. A function which is both one-to-one and onto function. So that's all about my explanation. I'm sorry if there are some mistakes in my video. Thank you for watching. and see you in the next video. Bye bye.